So now let's look at integrals that involve these inverse trig functions. So these integral formulas are just coming from reversing the derivative formulas. Right, here's our derivative formula. So if you differentiate inverse sine, you get 1 over root 1 minus x squared. So that means if you integrate the 1 over root 1 minus x squared, you're going to get back the inverse sine. So just think of it as take integrals of both sides here. So here, integral derivative cancel out up to a constant. So integral of that gives you back inverse sine. So that's this formula. And then integrate both sides here. And these cancel. So that is this formula here. So every time you have a derivative formula, you get an integral formula for free. So let's put these to work. Now notice we don't have one for inverse cosine, and that's because these two integrals only differ by a minus sign. What you're going to do is just factor out the minus sign, and you're going to do negative integral. And then we've already got that integral right here. It's inverse sine. So let's try and attack example number 8 here. We want to integrate 3e to the 2x over root 1 minus e to the 4x. Well, we got a square root in the bottom, so this is going to be an inverse sine integral rather than an inverse tangent. So we want to make it look like 1 over root 1 minus a quantity squared. And I look at this and I see that e to the 2x there, and I notice that, oh, e to the 4x is actually e to the 2x quantity squared. So I look at that and I see a function here, e to the 2x, and then its derivative is 2e to the 2x, and there's my e to the 2x. So I'm going to do a u substitution. So let's pull that 3 out. So I've got a 3 out in front, and now integral e to the 2x over square root 1 minus e to the 2x quantity squared dx. And then we're going to let u equal e to the 2x. So our du will be e to the 2x times 2, derivative of the inside, so 2e to the 2x, and then times dx because we're doing differential. And so we've got the e to the 2x dx up here. Let's multiply by the 2 that we need right here, and then compensate by multiplying by 1/2 outside. So now this becomes, we've got a 3/2 out in front, 2e to the 2x dx, that's our du. So now we've got integral du's up on top, and in the denominator, root 1 minus, there's our u squared. And so we've got that 3/2 out in front, and then antiderivative 1 over root 1 minus u squared is just this formula, but with a u, so it's going to be inverse sine of u. So this will be inverse sine of u, and then plus a constant. And so we just need to plug back in our e to the 2x. So this will be 3/2 inverse sine e to the 2x, and then plus constant. And we got it. Looks so easy when I do it, doesn't it?